Assalamualaikum and hi everyone. First, I will present the introduction of this study. Drainage and pipe works play an important role in construction projects by ensuring effective water management. They help to collect and discharge excess water, preventing flooding, waterlogging, and structural damage. In addition, proper drainage system protect infrastructure, maintain soil stability, and support the long-term sustainability of the development. The aim of this study is to examine the implementation of surface and subsurface drainage system and pipe works in a construction project, as well as to evaluate their importance in effective water management. To achieve this aim, 3 objectives were established. The first objective is to identify the types and functions of surface and subsurface drainage system used in the selected project. The second objective is to examine the pipe materials and construction methods adopted for drainage pipe works. Finally, the third objective is to evaluate the importance of drainage and pipe works in supporting flood prevention, groundwater control, and infrastructure sustainability. Next, I will present the case study 1. Case study 1 is to propose construction of a 3-story bucket hall with 1 semi-basement located at Bandar Baru Bangi, Selangor. This project focuses on the implementation of an integrated surface drainage system to ensure efficient stormwater management. The drainage system is designed to collect, convey, and discharge surface runoff effectively, helping to prevent flooding, protect the building structure, and maintain the long-term performance of the development. The project covers an area of approximately 1.486 acres. Construction will commence on 50 July 2023 with a contract duration of 104 weeks and is expected to be complete in July 2025. For the project team, the client is Perbadanan Kemajuan Negeri Selangor or PKNS. The architect is S&O Architect Sendirian Berhad. The quantity surveyor is RK Partnership Sendirian Berhad. The civil and structural engineer is DNP Consult Sendirian Berhad. The mechanical and electrical engineer is Jurutera Perunding Unggul Sendirian Berhad. And the main contractor is Kapa Jaya Sendirian Berhad.
Hi, Assalamualaikum. My name is Sofiatin and I will present this slide. This project adopted an integrated surface drainage system to efficiently collect, convey and discharge stormwater. This system consists of reinforced concrete drain, precast concrete block drain, pipe culvert and box culvert. Each component performs a specific function, but together they reduce the risk of flood, improve stormwater management. The construction process began with setting out to mark the drainage alignment, followed by excavation and bedding preparation. Next, the drain, culvert and sump were installed according to the approved layout, while cascade and step drain were constructed in sloping areas to control water flow. Finally, all drainage components were connected, tested and inspected before backfill and reinstatement were carried out to ensure that the drainage system operated effectively. Next, this slide presents the material used and the cost implication of the integrated drainage system. The drainage component mainly use reinforced concrete and precast concrete because this material provide high strength, durability and long-term performance. Other supporting materials such as cement mortar, lean concrete, reinforcement bar and filter aggregate were also used to ensure stable installation, proper structural support and efficient stormwater flow. Based on the BQ, the total cost for the drainage work was 332,000. The highest cost component was the precast concrete block drain at 128,000, followed by the reinforced concrete sump and reinforced concrete drain. This component required higher construction costs due to the use of concrete, reinforcement, excavation and installation work. Overall, the cost allocation reflects the importance of providing a durable and effective drainage system for the project.
Assalamualaikum, my name is Nur Aina Suhaila and I will present about challenges we are encountered during the construction works. First, excavation was difficult due to different soil condition and unstable ground. Second, rainwater accumulation interrupted construction and made drainage installation more challenging. Third, heavy drainage components such as box culvert and reinforced concrete drain required carefully handling. Finally, maintaining the correct element and gradient was essential to ensure proper water flow. To overcome these challenges, proper excavation planning and supervision were carried out. Water pump were used for dewatering. Mobile crane were used to install heavy components safely, and regular surveying ensured the correct element and gradient. So overall, this measure improved construction quality and ensured the drainage system was installed safely and effectively. Next slide, I will present the case study 2, which is the proposed construction of a single-story community hall and one refuse chamber. The project is located at Jalan Kasuarina, City of Elmina, Shah Alam, Selangor. It was developed to provide a community hall for the local resident. The total contract sum is 3.4 million with a construction period of 13 months from 31 July 2023 to 30 August 2024. The main parties involved are SMW Property, City of Elmina as the client, HIA Architect as the architect, Expertech Engineer as the civil and structural engineer, Juara Consult as the M&E engineer, Architect Urbanisma as the landscape architect, FS Associate as a quantity surveyor, and Jaya Bintang Sdn Bhd as the main contractor. Thank you.
My name is Nur Amira and I will explain the drainage and pipe works used in this project. The project used an open surface water drainage system to collect and discharge stormwater. Rainwater from roads, buildings and surrounding areas flow through drain and culvert before being released into the existing drainage system. The main components include precast concrete drains, brick sump, reinforced concrete sump, mixed steel trash screen, precast concrete pipe culvert and drainage connection. This drainage system helps reduce flooding, protect the surrounding area, and improve the overall drainage performance of the site. I will explain the construction process of the drainage system. First, the site is prepared and the drainage layout is marked. Next, excavation works are carried out to form the drainage trench. After that, brick sumps and precast concrete drains are installed according to the design. The pipe culverts are then placed to allow water to flow under the roads and access routes. Next, reinforced concrete sumps and trash screen are installed to collect debris and improve water flow. Finally, backfilling, testing, inspection and site cleaning are carried out to ensure the drainage system is completed properly and function as designed. This slide shows the main material used for the drainage works. The project used precast concrete drains because they are strong, durable and quick to install. Reinforced concrete sumps are used to collect stormwater before it enters the drainage system. Brick sumps are constructed to provide access for maintenance and inspection. The project also used steel reinforcement fabric, and steel accessories to increase the strength and durability of the concrete structure. These materials help ensure the drainage system is safe, durable, and has a long service life. Finally, the cost implication of the drainage works. The largest cost is the 225 mm diameter half-round precast concrete drain, which represents about 81% of the total drainage cost. These remaining costs cover the brick sumps, reinforced concrete sumps, trash screen, pipe culvert, drainage connection, labor, machinery, transportation, testing, and supervision. Although the initial cost is relatively high, this investment provides long-term benefit by reducing flood risk, lowering maintenance costs, and improving the efficiency of the drainage system.
Assalamualaikum. My name is Nur Fatal Zika. This slide shows the main challenges encountered during the construction of the surface water drainage and pipe works together with the solution implemented. Some of the key challenges include maintaining the correct drainage gradient, dealing with the heavy rainfall, installing multiple drainage components, handling heavy precast elements, and coordinating with other construction works. This issue can affect the project quality, safety and construction progress if not managed properly. To overcome these challenges, accurate surveying was carried out to ensure the correct levels and alignment. Temporary drainage and dewatering system were used during rain weather. Regular site supervision and inspection helped maintain construction quality, while proper lifting methods prevented damage to precast components. Lastly, effective communication and coordination among the clients, consultant and contractor ensure that the project was completed smoothly and efficiently. Next, I will present the comparative analysis between two case studies. Case study 1 use integrated surface drainage system, while cases 2 use the open surface water drainage system. Based on the comparison, case study 1 is more suitable for large and complex development because it has higher drainage capacity and provides better stormwater management. However, it requires a more complex construction process and higher construction costs of approximately 368 ringgit. In contrast, case study 2 is designed for a smaller development. It has a simpler construction method and a lower construction cost of approximately 169,864 ringgit and 80 cents, making it more economical options. However, open drains are more exposed and can easily become blocked by leaves, rubbish, and sediment if regular maintenance is not carried out. Overall, the comparison show that both drainage systems are effective in managing stormwater, but the most suitable system depends on the project size, site condition, and budget. In conclusion, this study shows that effective surface and subsurface drainage systems are essential for managing stormwater and preventing flooding. Although both case studies use different drainage approach, they successfully meet their project requirements. Overall, the objective of this study were archived, and findings can help improve future drainage design, construction, and maintenance. Thank you.